Hi everyone, welcome to the channel. So today's topic is we distribute yet things multiply of class 8 Ganita Prakash. So this video is completely based on the new textbook and it's a one shot video where you'll find this complete chapter, all the concepts and some important questions also that generally comes up. So if you haven't subscribed the channel, do subscribe it because you'll be seeing all the chapters in just one shot. So let's get started. So first is properties of multiplication, distributive property. See, whenever you have bigger numbers, when you have big numbers and it takes some time to definitely multiply the numbers. So this distributive property helps you to easily multiply bigger numbers. So what is this property about? So if I take a into b plus c. So bracket means multiplication. So this is nothing but a into b plus a into c. Same goes with subtraction as well. A into b minus c. So the top one was multiplication over addition, multiplication over subtraction. Same. A into b. Now this time it is subtraction minus a into c. So this is how distributive property works. Where you have two operations, add plus multiply and addition or multiply and subtraction. Next is commutative property. Commutative property is a plus b equals b plus a. Now for example, if I have 2 plus 3, I get 5. But if I interchange 3 plus 2, I still get 5. So in addition, even if you change the position, the answer doesn't matter. Same with multiplication, a into b is equal to b into a. Now let us see a question. This one simplifies to this plus. What is this dash? So these questions generally come for 1 mark. So bracket means multiplication. So 5a by 2 into a is 5 by 2a square. 5ab by 2, and then lastly 5a by 2 into 1 by 7, which is nothing but 5a by 7 into 2, 14. So 5a by 14 is your answer. Now, next up, the product 17 into 12 can be expressed as, now see, if you see here, you're getting 5, isn't it? So, basically 17 is there. 12 can be written as 5 plus what? 7. So that is why here the distributive property has been used. 17 into 5 plus 17 into 7. This is how you use distributive property. So this calculation becomes easier. Next, increments in products. Product. So let me take two variables a and b, a into b. Alright. Now if I increase this product, let's say I am increasing b by 1. So then, b by 1. So now what will it be? A into b is increased by 1. Increase means plus 1. So what do I get? AB plus A. Initially it was AB, isn't it? Now let me take, if I increase both by 1. If I increase A and B by 1. So A becomes, see, A becomes A plus 1. B becomes B plus 1. Both I am increasing. So what is the final increment? So how do I do that? A multiplied by B, A multiplied by 1. Similarly, 1 multiplied by B and 1 multiplied by 1. So if the original is AB, yes, the original is AB, but when I increase both by 1, what is the increment? This part is the increment. Yes. So let us see a similar question on this. Rahul is selling selling gift boxes. Rahul sells X boxes each day at a price of Y rupees. So number of boxes X, cost is Y rupees. Okay. Next. So his daily earnings are X into Y. Earning is X into Y. Okay. One day Rahul decides to increase the number of boxes by 1 and price per 1. So X is also increased by 1 and cost is also increased by 1. So this is the new earnings. So the question is, by how much has his daily earnings increased? So new earnings will be X plus 1 into Y plus 1, because originally it was X into Y. Both of them has increased by 1. So now how much has it increased? Let us find. So X needs to be multiplied by the other bracket. X into Y plus X plus 1 into Y is Y plus 1 into 1 is 1. Yes. So this much is his new increment. So initially was xy and the increment is x plus y plus 1. So this is how we find the increment. Next up is multiplication by 11, 101 and 1001. It is very easy when you need to multiply these. Here I can use what? Distributive property. So let me take a bigger number 3874. Let us multiply it with 11 first. How do I do that? 3874, 11 can be written as 10 plus 1. Yes. So what is the distributive property? 3874 multiplied by 10 and 3874 multiplied by 1. So what do I get? 38740 plus 3874, which will give us 42614. Similarly, if I have 3874 multiplied by 101, same procedure. 3874 into 100 plus 1. 101 can be written as 100 plus 1. So 3874 into 100 and 3874 into 1. So what do I get? 387400 plus 3874. The answer is 391274. Now 1001. 3874 into 1001. Same procedure. So 3874 into 1000 plus 1. See? These are very easy because when you multiply with multiples of 10, it becomes easier. So that is what everywhere we are just using distributive property. So distributive property helps us to multiply easily. Yes. Now let us see this one question over here. The price of the ticket is 89. What is the price of 100 such tickets? 100 such tickets. One ticket is 89. So 89 into, you need to find 101 tickets. So 89 into 101. Same, I can write 89 into 100 plus 1. So 89 into 100 plus 89 into 1. 8900 plus 89 will give me 8989 rupees. So easy. So rather than doing 89 multiplied by 101, you can also do this way. Next up, let us see the next question. A factory produces 876 machines every day. Yes, find the number of machines in 999 days. So now here, see, every day it produces 876. So in 999 days it will produce 876 into 999. Yes. So how do I do this? I can write 999 as 1000 minus 1. See, distributive multiplication over subtraction. Now 876 into 1000 minus 876 into 1. So 876000 minus 876. which will give me 875124. Easy peasy. Now next one is find the number of machines in 11 days without long multiplication. See, you will be awarded marks only if you do this procedure and not long multiplication. Even if you do long multiplication and you're ending up with the right answer, the teacher will not give you marks. So these properties should be used wherever required. So 876 into 11, which is nothing but 876 into 10 plus 11. So 876 into 10 plus 876 into 1. 8760 plus 876, which will give me 9636 number of machines. Yes, so you should be using these properties only, then you gain marks. Next up is calendar. Observe the multiplication grid. Each number inside the grid is formed by multiplying two numbers. If the middle 3 by 3 frame, see this red color frame is given by the expression PQ, you need to complete this whole grid using PQ. So if I see this PQ, the middle PQ is nothing but 4 into 6. So I can take P as 4, Q as 6. Yes? Okay. Now if I want to write 3 into 5, 3, how do I write 3? 3 is 1 less than 4. So can I write 3 as P minus 1, which is 4 minus 1? And 5 can be written in two ways. It can be written as P plus 1 or Q minus 1. Either way is right. So this whole block needs to be filled in terms of P and Q. Wherever it is increment, where it is decrement, plus 1 and minus 1. Now suppose 3 into 6. 3 into 6. So there is no space here, so I'm going to write it here. So 3 is again P minus 1 and 6 is nothing but Q. So P minus 1 into Q. Similarly, 3 into 7. P is 3 minus 1. Now Q can be written as 7 can be written as 6 plus 1, which is nothing but Q plus 1. And so on, you can just fill up this table in terms of P and Q, where you need to add, subtract. So we already have the values of P and Q. Accordingly, you can do plus 1, minus 1 wherever required. Now, next up is identities. Very, very important. Identities are very important. So, you have three basic identities. Let us see this. Suppose I have a plus b whole square. Yes. So, a plus b whole square is nothing but a plus b repeating two times. A plus b into a plus b. So, let us see what are we getting. So, a multiplied by a and a multiplied by b will give us a square plus ab. Similarly, b into a, b into b square. So, what do I get? A square plus 2ab plus b square. See, ab and ab can be added. All the like terms can be added. So, a plus b whole square is this one. So, this is one very, very important identity which you all should know. It is very commonly used. A plus b whole square is a square plus b square plus 2ab. Now suppose if I have 2x plus 4x. These are like terms, isn't it? Because they have same variables. So 2 plus 4 is 6x. That is how I added ab plus ab is when there is no number, it means 1 by default. So 1ab is 2ab. Next up is a minus b whole square. A minus b whole square means a minus b repeated two times. So if I again multiply a into minus b, a square minus ab. Now b into a and b into b. So minus ab. Now minus into minus becomes plus b square. So what is the formula? A minus b whole square equals a square. Now minus 1ab minus 1ab is minus 2ab plus b square. This is the second identity. These are very, Now the last one is a plus b into a minus b. So what do I get? A into b is a square minus ab, b into a, b into b. So plus ab minus b square. So I cut this. So ultimately my identity is a plus b into a minus b is a square minus b square. This is how these formulas are formed. So these are all the identities. Identity means these are the facts. So whatever values you put here, whatever values you take, you get LHS same as RHS. This is what an identity is. Next up we have this a plus b whole square is greater than a square plus b square for all integers a and b. Is it true? So let us find out this. Firstly, a plus b whole square is what? A square plus b square plus 2ab greater than a square plus b square. This is given. Alright, now let us assume if a is negative. Okay, if a is negative, what do I get? Minus a plus b whole square. Yes, which is nothing but a square plus b square minus 2ab, because a is negative, instead of a I'll put negative sign. Yes, okay. Now a square plus b square, both are same, but you have minus 2ab. That means from a square plus b square you are subtracting something. So this cannot be greater. No, this is not greater. But if I take a as positive, so what do I get? A plus b whole square, a square plus b square plus 2ab. Then it will definitely be greater than a square plus b square, because this is one extra that has been added. So if a is positive, it will be true, but if a is negative, it is not satisfied. So your final answer is no, because it has asked for all integers. All integers means a, b can be negative as well. So the answer is false. But if they have asked you that only for natural numbers starts from 1 onwards. So if it is positive, if both a and b are positive, then the statement would have been true. But since it is for all integers, the statement is false. Now next up we have a question. A square field has a side x plus 7 meters. A farmer, see, here you already have the figure. Sometimes the figure will not be given, and this is one of the most important question. You can see a square field outside. Green color is the square field. A farmer wants to build a square pond of side inside the field. See, inside the field, this is a pond, blue in color. The side is x minus 7. Express the area of the remaining land algebraically. Remaining land as in, see, blue color is the pond. So this green portion is nothing but the land. So how do I find the remaining land? Remaining is equal to area of outer minus area of inner. See, from the outer area, if I subtract my inner area, I'm going to get the green portion. So outer area, what is area of a square? A square. And what is the side given? X plus 7. So x plus 7 whole square, side square. Similarly, inner area is going to be x minus 7 whole square. Yes. Now here let us just apply the formula. A plus b whole square is a square plus b square, 7 square is 49, plus 2ab, 2 into 7, 14 into x, 14x, minus, now this one, x minus 7 whole square, a square plus b square minus 2ab. Now let us open up the bracket. X square plus 49 plus 14x minus x square, minus into plus minus 49 minus into minus plus 14x. So this is it. So plus x square minus x square cancel, plus 49 minus 49 cancel. So we are left out with 14x plus 14x, which is 28x. So this is nothing but the area, meter square. So this is the area of the land algebraically, as in where it have x. Now next bit is, if x is 10, calculate the remaining area. What is the remaining area that we found? 28x? Yes. So 28 into x is 10. So remaining area is nothing but 280 meter square. Next up, patterns. Very important, patterns. See, a pattern of dots grows as follows. In step 1 it had 4 dots. Step 2 you can see it has 10 dots. Step 3 18 dots, and so on. See, you need to understand what is the pattern. 4 dots, 10 dots, 18 dots. So if we understand the pattern, then we can frame the general formula. We need to find the general formula. How do we do this? Now, first one is 4. Step 1, 4 dots. How do I get? So basically this is nothing but first step and into 4. Okay. Let me just erase. I need some space. So let us do it here. So first step is 4. Second step 10. Third step 18, and so on. So how am I getting 4? Let me take 1 into 4. First step is 4. Now second step into 2 into what gives me 10? 5. Now third step, 3 into what gives me 18? 6. Isn't it? So what are we seeing here? It is 1, 2, 3 are nothing but the steps. First step, second step, third step. Yes. So to write the general formula, k into, now this second value, how am I getting the second value? 4 is nothing but 1 plus 3. Okay. 5 is nothing but, okay, let me write. 5 is nothing but 2 plus 3. 6 is nothing but 3 plus 3. So if I find for the fourth one, it is going to be step into 4, 5, 6. Next should be 7, which is 28. Now 7, if I see, it is 4 plus 3. So 3 is a constant, isn't it? Every time it is increasing by 3. But what is this 1, 2, 3? These are the steps. So the step, first step, second step, I can take every time. To k we are increasing with 3. Isn't it? So my thing is k into k, k square, k into 3, 3k. So this is the general formula for this pattern. So how did we find? We have segregated, we have divided. How can we write 4, then 10, then 18? We need to find the pattern and then write it in the algebraic form. Now here the B part is, we need to find the 15th term. So on step 15, how many dots? So once if we have the formula k square plus 3k, we can find in whatever step, in whichever step we want, how many dots will it have. We can easily find out. So now this time k is 15. We want for the step 15. So 15 square plus 3 into 15. 15 square 225 plus 45, which will give me 275. Yes. So on step 15th you will have 275 dots. So this is how, because you cannot keep doing now step 4 you cannot keep doing for 28 dots and so on, isn't it? So to find the formula, it is easier to find the number of dots in any step. So as I mentioned, the chapter is really small and we have completed the chapter. It only has these topics. So see you in the next video with the new chapter. Till then, if you haven't subscribed to the channel, do that and take care. Bye.